We are going to solve a problem on projectile motion. So as you can see, we have a picture and there is a ball which is rolling on the table. And the question says, once the ball leaves the table, calculate how long it will take for the ball to hit the floor. Now, we know that projectiles are basically any objects which is just under the influence of gravity and there is no other external force acting on it. And it's basically it demonstrates the combination of two different types of motions, horizontal motion and vertical motion, and both of these motions happen simultaneously in free air. So what happens is when we look at a projectile, so when this ball comes off the table, it starts behaving as a projectile. So it will be just under the influence of gravity at this point. All right. And it will still show the horizontal motion and it will still have the velocity of 10 meters per second acting horizontally, but at the same time there will be a vertical force pulling it downward, and that force is going to be the force of gravity. So as it starts coming downward, it will accelerate because of the force of gravity, and at the same time it will also continue moving in the forward direction because of the horizontal velocity. So the question says calculate how long it will take for the ball to hit the floor. So what we are going to do is, if we have to calculate the time it takes to reach the ground, now that we will be able to calculate using the equations from kinematics. So we know the initial velocity of the ball right after it comes off the table in the vertical direction is going to be 0. So initial vertical velocity is 0. Now, as soon as it starts coming down, the more it comes down, its velocity increases more and more. And finally, before touching the ground, it will be having its maximum velocity. All right. Now, we know the height of the table is given to us, which is 1.5 meters. So what we can do is, we will be utilizing the height equation. So height can be written as 1/2 gt square from the equations of a projectile. Now the height is 1.5 meters, which should be equal to 1/2 times gravitational acceleration, which is 10 times t squared. And if we solve this equation, so we can write 1.5 on the left hand side is equal to 10 divided by 2, which is 5 times t squared on the right hand side. Now if I divide both sides by 5, we can eliminate this number 5 from the right hand side, and we will have t squared equal to 0.3 on the left hand side. So t will be equal to square root of 0.3, which is 0.54 seconds. So this is your answer for this first question. So now this is a continuation from the first question. So from the first question, we have already derived the time it takes for the ball to reach the ground, and the time was 0.54 seconds. Now let's look at the second question. It's saying calculate the resultant velocity of the ball before it touches the floor. Now right before it touches the floor, there will be two different types of velocities. One, the horizontal constant velocity of 10 meters per second, which will be acting in the forward direction. And there will be another velocity, the vertical velocity, which is due to the force of gravity. So right after the ball leaves the table, at the beginning, we know the vertical velocity is 0. VI, initial vertical velocity is 0. There is no velocity at all. The more it starts coming towards the ground, it starts accelerating further and further, and finally, right before it touches the ground, it has maximum velocity. So we need to calculate what is the maximum vertical velocity right before it touches the ground. So we will be applying one of the equations from kinematics, which is final velocity equals initial plus gravitational acceleration times t. So we are looking for the final velocity. Initial velocity is 0 at the beginning, plus 10 times the time taken to reach the ground, which was 0.54, which is what we have already derived. And that's how, if you multiply 10 times 0.54, you get 5.4 meters per second. So this is the maximum vertical velocity right before it touches the ground. So you can see you basically have two different vectors acting together simultaneously on the same object. So we have 10 meters per second acting in the forward direction, 5.4 meters per second acting in the downward direction. So we need to find the resultant velocity. So the resultant velocity will be a combination of these two vectors. So let's draw this vertical vector of 5.4 meters per second, and let's form a right angle triangle over here. So this vertical vector is equal to the vertical vector on this side. So we can write this as equal to 5.4 meters per second. Now this is forming a triangle, a right angle triangle. And you know, whenever you see such right angle triangles, you can find out the hypotenuse by applying the Pythagorean theorem. So for the resultant, we are going to do the same thing. R square equals 10 square plus 5.4 square. So that's going to be, if you solve it, you get 100 plus 5.4 square. It's going to be 29.16, which is going to be 129.16. And now we will be taking out the square root of 129.16. And if you take the square root, of 129.16, you get 11.36 meters per second. That is your resultant velocity. So your resultant velocity of the ball is going to be 11.36 meters per second. Now let's write down what we know from the previous two problems. We know the time, 0.54 seconds is the time taken by the ball to reach the ground. We know the resultant velocity of the ball, which is, the resultant velocity was 11.36 meters per second. Okay, and now we are looking for how far will the ball travel horizontally before it hits the ground. Now, for this horizontal travel, when we are talking about the horizontal travel is basically the range of the projectile. Now, the range of a projectile is just dependent on the horizontal velocity, and the vertical velocity does not have any role to play in covering the range. So we'll be just taking into account the horizontal velocity of the projectiles. So we will be writing range of a projectile is the horizontal velocity, Vx, which is 10 meters per second, multiplied by the time taken to reach the ground. So it is 10 times 0.54, and that's going to be 5.4 meters. So 5.4 meters is the range of the projectile. I hope this problem has been, you were able to understand how we solved step by step all the entire problem. And if you have any questions, let me know in your comments, and I can solve some similar problems again for further clarification. Thank you.